Perfect. Hello, everyone, and welcome to the sixth breakout call of EIP 7928. It's November the 5th. And let me directly post the agenda into the chat so that everyone can have a look. We have quite a few topics because I put all the spec changes we made since the last breakout call into the agenda today, just so that people are aware of what happened since last time. This basically includes fixing how we track withdrawals. So you might remember in the last breakout call, we discussed how withdrawals are handled, and we had some bugs there in the specs. Besides that, um, yeah, there weren't any other major changes, at least as far as I'm aware. Maybe Felipe or Rahul, if you want to add something to that, feel free.
I think that covers it, Tony.
Perfect. Awesome. Yeah, have a look at the agenda. I linked all the specs, and besides that, you can see the agenda point proposed changes, and this is then directly the first topic that we should discuss today. Namely, do we want to include gas used values of each transaction in the block 5 access list? And I've already spec'd it, so you can look at the specs how it would look like. And the main motivation behind this change was allowing clients to better parallelize transactions and avoiding worst cases that originate from not being able to distribute transactions evenly across your cores. So I'm not even sure if this is the right mental model I have on that one. So I'm curious what client teams think about this one. If the gas used is actually something that would be helpful, or if you think like just naively parallelizing them in the sequence, how they are in the block, is good enough, or might even yield the same results. So if anyone has thoughts on this one, I would assume that the default is just we don't do it, but I think we should consider it, at least thinking of certain worst case scenarios where you could end up with big transactions being executed on one core while other cores might idle.
So personally, I think it's really hard to say that how much performance gain we can have by adding this inductor. One good way is we can try to compare the execution time with this gas used indicator or without, so that we can like try to measure the real block, and then we can decide if we want to include it or not.
Yeah, good point. And maybe just one question I would have regarding that. What would actually change if I give you a list of the gas used values? Would you just modify the order in which you present transactions to the executor?
Um,
Or is there a process where you're really like, okay, I have transaction 3, 5, and 7, and they are all very big, so I make sure I distribute them across core 1, 2, and 3, and make sure they are not landing on the same core. Is there even something like this happening?
I haven't really like thought about it, but I guess we will try to schedule the heavy transaction first, so that they can be there's no waiting time, and we can try to give it like more execution time. Yeah, it sounds like a very naive approach. Like we schedule the heavy transaction first, and then try to emit the transaction one by one to different threads. Yeah, but I don't have like any like useful comment for it because I never I like haven't did any experiment about this.
Yeah, Dragon.
I think it's not worth it. Rough math around that, the worst case, if the stealing of the like scheduling of transaction to the cores is done correctly, the worst case can potentially be because we have like 60 million cap limit, 60 million gas per transaction. The difference is like 50% faster execution when everything is parallel. With both, that the speed up is like 3-4 times, 50% doesn't matter at all. So it doesn't, if the work stealing is done correctly, I don't think it's worth adding that.
Yeah, I see your point. Yeah, the example, a more tangible example might be assuming 60 million gas, and we have like, or a bit above 60 million, we have four. Let's say we have one max size transaction, and all the remaining gas is consumed by ETH transfers, for example. What you would want to avoid is executing all the ETH transfers before the big transaction. So what you want to do is parallelizing them, I guess. Yeah, but I can see your argument that it might just not be worth it, and just confirming also what Gary said. Go ahead.
In general, at least I still didn't. I'm not sure even if I'm going to implement that, but you want to implement something like stealing transaction. You have 4 threads or 4 cores that execute in the parallel, and they steal for one single queue. And whatever the core finish executed transaction, it steals another transaction from the queue. In that sense, every core that wants more work will steal the task from that queue. At least this is like one of examples how could this like work. Worst case for that, if the last task is the biggest one. And the biggest task is 60 million, so it's like, it's not worth it, to be honest.
So compared to like 60 million gas limit, it's already like 1/4. And compared to like 100 million, like the effect will just become smaller and smaller.
Yeah, exactly.
Yeah, anyone else who wants to chime in, voice an opinion? Otherwise, we don't have to take a decision today. Anyways, the default would be just we don't change anything, and the gas used would stay out of the block level access lists. We can also use the time around Dev Connect to discuss that further. Maybe clients get to comparing how they would eventually parallelize. But in general, I agree. This argument of Dragon does make a lot of sense that we might improve the worst case, but it might not be worth it.
Hello, Tony. I
Yeah,
have
go
a
ahead.
question. Because I joined later, the question is, shall we schedule the transaction execution by gas used?
Yes, exactly. If we put the gas used values into the block level access list, if this is kind of useful information for parallelizing.
Okay, I recently just did an experiment with gas limit. Yeah, it seems this information is enough, and it seems the most time consuming transactions will dominate the block execution time. Yeah, maybe later I can show a demo so you can see the results. Yeah, we can schedule just by the gas limit. Yeah.
Exactly. Yeah, these are like there are three options: scheduling just by, or four options: just naively scheduling by their order as they are in the block. Then you can use the gas limit. Then you can use the gas used, which would require us to add it into the block of access list. And the most hacky solution would be you take the balance diff, and from that you infer the gas used, because every time you pay fees, it's also a balance diff. So yeah, it might be attackable, and the cleanest solution would be to just use the gas used. But as Dragon said, worst case scenarios are still like very contained by the 7825 transaction gas limit, and we might just ignore the whole topic and don't include it. But yeah, definitely happy to look at your results there.
Yeah, so sorry, just I joined a bit late, so I'm not. So one of the things that we've discovered with parallelization in Aragon is we've basically ended up with two phases. We do the execution phase, and then we do the receipt phase at the end, because depending on the order in which parallel execution is happening, if you use a common gas pool, it basically you're going to go out of gas essentially, when in fact you wouldn't once you get to the end of it. So having the gas per execution would make that process a lot easier, basically, because it means while you're when you execute a particular transaction, you can check its gas at the time, which you generally can't do when you're executing in parallel, because you don't know the order, if you see what I mean.
Yeah.
Yeah.
Yeah,
So,
this is exactly the argument.
yeah.
I had to, yeah. Dragon's counter argument is like that even if it turns out you scheduled them in a way where you did like the worst job possible, for example, you were tricked into scheduling that way, then the worst case would still be like you would maximally have like one transaction on top while all cores are idling. And this transaction only has a size of 16 million, which is like 1/4 of
Yeah, well, it's
the 60
more.
million.
The problem is more that if you've got transactions with reverts in the middle of them, as you're processing, the transaction looks like it's using more gas than it should do. And what then happens is it's generally fine, but if you're in a full block and you get to the final transactions, you can basically run out of gas too soon, if you see what I mean. So you get a set of edge cases around failing blocks on gas when actually they don't, because effectively the transaction looks like it's using a lot of gas, then it reverts. So
I'm not exactly following this use case. Are we talking about if the transaction is not spending exact amount of gas that it should be, or something else?
well, I mean, the transient gas cost of a transaction changes depending on whether it reverts or not. And basically, that means you end up with some cases when it looks like they're overusing gas. So you get out of gas sooner than you expect. If you know what the transaction gas is, you're never going to hit that situation.
You mean if the transaction reverts, all the gas is spent, even if the gas is not like used? Let's say it like that.
Yeah, it looks like it's. So it depends to some extent. It depends how you're doing the gas calculation.
Yeah. Then this is like good case where transaction should take a lot more time, but in the reality it takes 1/10 of time than it should be. That's like, yeah, it's faster to execute than we expect from the gas. Okay, that's a good comment.
Yeah.
So
Well,
just to be clear, does this? Sorry, go ahead.
It just executes differently, and basically what we've discovered in testing is you get the occasional block that you go out of gas right close to the end, basically, and it only impacts full blocks, basically, or fullish blocks.
Yeah, I don't fully follow, but just to be clear, like the implication of this of not having the gas used here is basically that if that we can't invalidate a block for the actual gas use of all the transactions going over what is allowed by the gas pool. We can't do that until we have to execute all of the transactions and validate it at the end, right?
Yeah.
In the collection of the receipts. That's the issue you're getting at here?
Yeah, that's the issue.
Okay.
I see. So essentially, at the very end, you would go through all the transactions again and determine if they actually fit into the block.
Yeah, which, in practice, it's not a very computationally heavy process, so it doesn't make much difference to because the thing is you need to do that for the receipts anyway, because you need the aggregate number as so you end up having to total the receipts at the end anyway. And
Right.
comparatively, it's very little processing to do that, so you don't get a big advantage in doing that. Well, doing that whole process at the end doesn't seem to cost much time in terms of the scheme of processing a block.
Right, and then
the main downside is just that you can't know that the block is bad until you've processed all the
correct
transactions in the circumstance. So
right, but this is not really a DOS vector or anything. So to me, it feels like this is not really a strong argument for having the gas used values in the block level access list. I do see why it makes this process cleaner, because you could just compare each transaction individually and independently to the gas used value in the block level access list.
Yeah. Yeah, so it's a nice to have,
good point.
basically. So in the scheme of things, it's a nice to have.
Right, yeah. Yeah, I agree to that. Yeah, I think for now we would not include it, but yeah, we still have some time to decide this topic. We don't have to take a decision today. So we can also discuss during Dev Connect and at the next breakout call again. Yeah, it's good that we have brought this topic up so that people are aware of this possibility. Any more comments on that? Perfect. Then let's move on to the next agenda item. Actually, the next agenda item is client and DevNet updates. So if you want, Stefan, I would invite you to give us an update there.
So we overhauled a little bit how we do DevNets. We added a new boot node setup. So that's why we've been kind of iterating on our side a little bit. I can also share kind of the spec update that I haven't mentioned yet. PK has added EVM fuzz tool to the spammer that we can use. It basically creates contracts with different opcodes. And if you run that with different client pairings, there's still a few issues that can be found. So I would generally kind of waiting for a very or relatively stable kurtosis testnet and to see that all clients are decently working together. And I think also with the spec changes, it would be good to get some client updates also, kind of where we are at, because it's wouldn't make sense to spend money on the DevNet if it's not running stable yet.
Yeah, thanks for the update. Maybe let's ask client teams, how far in the process are we, or how close do you feel being able to join a DevNet? When it would make sense, of course.
Yeah, I guess I'll just go. I think that Geth is mostly ready, but like, so we just had this new test release. So essentially the Coinbase issue hasn't been entirely settled in Geth. But other than that, we would be ready to go.
On Bezu, we are passing all of the tests related to Amsterdam, but we have, I think, as this other client, we have a lot of issue in the tests that are testing old fork. So I'm not sure if we want to be sure that we are passing this test before starting the DevNet, or if we just say that it's bad configuration of the test, and we will see maybe in the next version if it's okay. Because we don't really know if it's just because of a bad configuration in the test or if it's really a real issue or something like that.
Yeah, do we have someone? Yeah, sorry.
I was just going to say for Nethermind, it's the same, just going through these new tests, this new test release and just checking why some of these tests are failing.
Same with Red. I don't have any pending items on both side, so fixing tests on spec side, running them to confirm that everything is okay. It's like the next thing, and after that, I think DevNet 0 could be spun up.
So where we are from an Aragon perspective is we've now got an implementation that we're testing. We're getting quite a few Hive test fails. So Chom, who's actually working on it, is not on the call because it's not good from a time zone perspective. But I'm wondering if there's somebody he can contact just to find out whether, because it's the first time we're going through, he's trying to work out whether the fails are us or DevNet issues, testnet issues, or Hive issues. So it would be good if there's somebody that we can put him in touch with, because we're kind of bootstrapping the Hive process at the moment.
Yeah, definitely. So I think the two people with the most insight on that process are Felipe and Rahul. So yeah, Rahul, I just see you on the call of Felipe. Maybe you could get them a little bit.
Yeah. I'd like to catch up with everyone on the state of the tests. So there are a few spec changes that are needed that actually impact. So this is based on conversations on the block access list, Ether and D channel. There's a more recent conversation with Sam, who's been leading the execution specs project. And these changes are going to actually impact the specifications for all forks. And so what I want to do right now is release a patch for the tests that has the changes that we need so that we can generate cleaner tests for block access lists. And this includes all the old forks. So what this release did is it basically filled all of the tests that we have in our test repo across all of the forks, generating block access lists for all of them. And so I expected quite a few failures because this will reveal edge cases that we just haven't written targeted tests for block access lists yet. But knowing that there are spec changes that are needed, means right now it's really hard to tell which tests are actually bad tests and which ones are failing because the specs aren't up to date. So there's this discrepancy of resolving the specifications quick enough for Amsterdam at least, so that we can put out a patch release for the tests, but also ultimately we have to go back and fix the specifications. It's basically related around charging gas for memory expansion and loading account earlier within each call, and then continuing on with the call afterwards, so that we only track the account if we have enough gas to track the account and things like these. And so, yeah, unfortunately, the current state of the tests aren't very representative of what the specifications should be currently.
Thank you very much for the update. Yeah, I've just posted the PR I'm working on in the chat. Just to summarize, there are two things. Some things are more like cleaning up. For example, putting the state tracker into the block environment instead of the state. The more crucial thing you were referring to is really kind of splitting up the charging gas from checking the gas and making sure that if we run out of gas, or let me put it differently, that we never put an address into the block level access list or any entry into the access list when we run out of gas afterwards. Right. So you want to kind of I think Dragon was saying that, or who was, I don't remember who brought it up, but is that already like addressed in my PR?
I'll need to go back. This is the new PR, right? After we've had conversations with Sam.
Right. Yeah.
Okay. Yeah. So I also posted my gas charge split PR, and this does stabilize all the bad tests. And I'm not sure if this is all of the changes that we need, but I think this covers most of them. And it does have all of the targeted block access list tests that are up to spec passing. And so I feel like this PR that I worked on, and whether those changes are also in your PR, some version of that is what we need for a more stable test release.
Perfect. Yeah. Then I will take those changes out of my PR and just leave it at this refactoring where we move the state tracker around.
Yeah, that sounds great. Internally, I think I would like to get the Steel team on board with putting these changes up for Amsterdam first, and then we can focus on the full forks refactor to how the specifications charge gas in general after the fact, so that we can get our tests up to speed.
Perfect. Thank you. Awesome. Yeah, I haven't seen your PR yet. I will review it. Perfect. Any other updates we should discuss regarding testing, regarding the specs, making sure we don't forget anything? I'm relaying this message from Stefan that clients please run the EVM fast scenario for spammer. Great. If there's nothing else, then we can move on to the next agenda item, which is a rather old topic. It's still about, do we want to include the reads or don't? With reads, we usually mean the state locations, so unmodified accounts that come with empty lists of changes objects and also storage keys. So everything that is touched within a block but not modified. We have discussed that topic a while ago, and Gary did some benchmarks very recently. Gary, are you on the call? Do you wanna quickly share what you did there?
Yeah, I can share my write-up. Can I share my screen?
Yeah, should work.
Okay, can you see my screen?
Yeah, I can see it. Yeah.
Yeah. So I've been discussing with Tony recently about whether it's worthwhile to include the read location in the BAL. So at the beginning, I was at the opposite side because I think it's not that easy to correctly gather all the relocation during the block execution. And because we need to compare the BAL data in the consensus, so if we provide like slightly different data, then the consensus will fail. Like I am not very confident about it, so I suggest that maybe we can exclude the read location in the initial version. But yeah, later I try to measure the performance gain we can have by utilizing this relocation. So I think the intention of the BA is try to optimize the block execution, and so that we can push the network gas limit upward safely. But we need to ensure that the BL can benefit basically all the potential scenario in the block execution. One potential worst case I can imagine is that the read heavy block. And so now the gas cost for the cold S load is 2,100, and for the account access is 600. So with the current network gas limit, we can in theory have 28,000 S loading within a single block. Yeah, so I try to measure like how much time we need to spend if we want to access this that many storage or accounts. And with Osaka, like we limit the maximum gas limit within a single transaction to 16 million. So it means that we can at least have 4 transactions within a single block. So the baseline I have choose is thread with 4. So the first thing I did is I tried to measure the batch rate with different thread over the raw SSD. And yeah, it turns out that with thread 4, we can achieve this 70,000 QPS query per second. And with 128, we can achieve roughly 10x speed up. So yeah, and like it's the read performance over the raw SSD. And the next thing I did is I tried to perform this batch rate over a real Ethereum mainnet gas node. The background is that the database size is 288 gigabyte for the key value store. And yeah, so with 4 thread, the QPS is around 22K. And if we give like 128 thread, the QPS can go up to 200K. So it's 10x faster. And this number like totally changed my mind, and I think it's worthwhile because it is 10x faster for this particular real heavy scenario. And another interesting thing is I have observed is that before the thread 32, if we give more thread, like higher concurrency, the read performance will be increased linearly. But after that, we like hit the saturation point, and there's no significant performance gain by having more concurrency. So I think it might be relevant with the physical structure of the SSD, because internally it has some channel inside, and it has a specific capacity. Yeah, so let's say the saturation point is 32 thread, and given that for a single transaction, the maximum gas limit is 16 million gas. So I think we can say that before the network gas limit be increased to 500 million gas, the BAL with read location will still be beneficial for us. Yeah, but all the benchmark are performed over the gas implementation. Like different client can, because different client use totally different database, and the number might be slightly different or could be completely different. So I would recommend you guys to simulate the same thing, and to make sure like our number are aligned with each other, so that we can make the final decision to include it or not. Yeah, I guess that's it. I did link my benchmark program here, so if you want to have a reference implementation, you can check it out. Yeah, but otherwise, I think that's it.
Awesome, thank you very much. Are there any questions people have?
So one comment from me, because Gary used 28 thread CPU, so this 32 thread limit increases might be as well from the CPU being completely used, but I don't know. That might be a good thing to check. So maybe on different CPU and different disk, or like especially like disk in RAID, we could achieve even more scaling.
Yeah, it could be possible. So yeah, we can try to use different setup to run the benchmark again, and I think it's
sorry, so how many CPU threads? So how many CPU threads have you got? Because you should
in my setup, I use Intel like 147K. So it should have like roughly 20 cores for concurrency.
Yeah, so the question is
20 cores and 28 threads.
But so for disk I/O, it may be offloaded off the core. The interesting question is, if you have fewer cores and the same number of threads, what does it do to the performance?
Yeah, I think when I did my benchmark, like it is the only program I am running, so I would assume that it can use all the available cores. But as I said, in my setup, like I use this particular CPU and this particular SSD. If we use something different, maybe the number could be like slightly different. So yeah.
Yeah, I'm just wondering how much CPUs were doing, because they're basically doing disk I/O or device I/O.
So in this benchmark case, basically we have no CPU computation, because we assume it's a read-heavy block, and the read is the slowest operation. So for the worst case, it's just all the read without any VMIC computation.
Yeah, so that's what I'm saying. So that implies that actually your number of threads is not CPU dependent. You should be able to increase the number of threads you've got allocated to I/O, because the CPUs are just idle. They're probably waiting for the I/O to return. because it's the IO subsystem that you're loading. If you see what I mean. Anyway, so it'd be interesting to see what the numbers would look like on less threads. I mean, less CPUs, same number of threads.
Yeah.
Yeah, and it would be great if clients can also reproduce that individually, just if we have more data points on the topic, as well as we should try it with double the state size. So currently in Gary's analysis, the state was at 288 gigabytes. I think right now we have a state growth of like 60 to 100 gigabytes per year. So we should definitely try it with double the state size too, and see if this changes something in the numbers. But in general, because one thing we have to consider when it comes to the state reads is that the worst case block level access list size is also the exact same scenario. So we might end up in a situation where we have like the worst case block containing of a lot of storage reads, while a rather big block, it's not the worst case block because call data will still be allowing you to get to a bigger block, but it's a big block. So for example, at 60 million gas, the block level access list would be at like 850 kilobytes to 1 megabyte, which takes with 50 mbits takes 165 milliseconds to download. So this is all things we have to consider here. So if we like get something from the state locations, then it must be significant and it must be worth the costs we pay on bandwidth. But based on this analysis, it looks like it. And it looks like it tops at 500 million. So like at 500 million, we have enough transactions that you can nicely parallelize them. And then the benefits we get are a little lower or less significant. And yeah, go ahead, Mark. You want to say something?
Yeah, I was going to say the other thing though is that if you're when you start running parallel execution, if you parallelize the transactions, you get a fair amount of natural parallelized reads anyway, right? Because if you've got all your executions running, n of them hit a read, so you're running reads in parallel anyway. If you see what I mean. So some
exactly. That's why Gary took 4 as the benchmark, because essentially with 60 million transactions, you will be able to parallelize 4 transactions at the same time, which is essentially the same as doing like using 4 threads for reading, right? This is what you're referring to.
Well, yeah, and I'm saying basically, so if you've got all the in practice, if you've got all the reads up front when you start parallel execution, you'll kick off a set of parallel reads, but also you've got like a race condition in the sense that I don't think you wait to start executing transactions, and then kind of the early transactions will actually go to the disk themselves, right? Because they get there before the read comes back. And the question, if you care about bandwidth, is what boost do you get over the natural parallel flow, if you see what I mean? Because you could be driving the disk quite fast anyway, just from the parallel execution process. So you might not need you might not need the read list because the transactions will get there pretty quickly anyway. If you see what I mean?
Yeah, that's a good point, and that's I would say exactly the reason why we have to consider if reads actually give us enough to be worth the costs we pay. Right now, based off Gary's analysis, it looks like it is worth it because it was like 8x or something and in absolute numbers, a few seconds difference when we are at 500 milliseconds, or a few tenth of a second difference. If I remember correctly, like a little more than half a second of difference. And then it looks like it's worth the bandwidth costs we pay. But yeah, I think it's very close, and we should definitely get some numbers on different clients, different implementations of the simulations, and second, on a larger state. And yeah, maybe we can then take a decision as soon as we have it. I just see Dragon in the chat. There is EIP-7828, if I remember correctly, that defines like minimum hardware specs. EIP-7828, am I correct? Yes. I will post it into the chat.
Can we just implement both and run real world like testing later and decide closer to the deadline on that? Measuring both, right? Having both access list with and without, or like maybe distribute with, but then measure execution with and without, right? On one machine like that, and compare the actual results in practical blocks and worst case blocks too.
Yeah, it is like the intention I make this benchmark because we can like have a feeling that how much performance difference we will have. So like if we run the BAL in the real scenario, it would be perfect. But at this stage, the early stage, we can try to measure the performance difference with this benchmark first. Is what I'm trying to say.
Yeah. But I kind of agree that we need to go through, we should leave it. So I think leaving it in at the moment is a good idea. And we ought to leave it in for quite a long way through the DevNet process. Because once we've established some operating parameters, what we actually want to do is take it out and see whether it makes any difference. If you see what I mean. Because otherwise you really don't get the what does it do to the overall end-to-end parallel flow? Because one of the things that I've discovered testing parallelization in Aragon is you really need to have all the pieces together because they have different behavior when you test them individually. Basically, in the end.
So if we have them in for now, we don't even have to take them out. We just have to have a second implementation that doesn't use it, and we can compare it live, the difference on live
correct.
blocks.
Yeah, I agree with that. Because you can say, well, what practical difference does this have over your block time if you use it or you don't?
Yeah, I can see that argument. The only thing I was hesitant about was taking a late decision on that, because of course we would love to have the numbers today instead of tomorrow.
Yeah.
So I don't want to, I'm not sure if it's the cleanest approach to have like two releases running at the same time, or if we just do the benchmarks now and make sure we get to as realistic result as possible. I mean, from the spec side, it wouldn't be a big problem, but I would assume that in client implementations, it's not just taking them out versus leaving them in.
No, not really. It should be relatively easy to do because you just have a parameter if you load those in the background thread based on this access list, or you don't, or you just ignore this read access list, right? In a way.
Yeah, so it's true, but there are some edge cases attached, right? For example, if you revert and you have written to something in the specs, for example, we have this custom function that converts a write to a read for reverted writes. Stuff like this would then be needed to be commented out. But I agree, it should be possible to do so.
Yeah, and another point is that personally, I think there are so many edge cases in like collecting the read location. If we can somehow make an early decision that we don't want this relocation, it would be much easier for the implementation.
Right. Yeah. Yeah. The good thing is that we have them in the EIP right now, and clients are basically ready to ship them or on the track to ship them, compared to adding them later on, which might be way too difficult. So I would suggest we keep them in for now, but it's great that we now have more data points on that topic. And then it would be great if we can simulate it even more. Maybe we get some clarity before we even need to run multiple versions on a DevNet and compare them empirically. But yeah, let's see. Let's keep the discussion on that ongoing and keep the thread open. Is there anything else we should discuss regarding this optimization?
No, I mean, it's the summary of the discussion seems to be that benchmarks doesn't rule it out, right? It says actually it's potentially going to give a big enough performance improvement that we should continue with it. That was what I was hearing Gary saying, I think.
Mm-hmm. Yeah, and Gary's benchmarks were also like not super clear on what is the actual to do from them, right? Because they give us like a 8 to 10x with diminishing value with increasing block gas limit, but at the same time ignoring increasing state. So I think it's very difficult to tell if it's worth it or not just based on that. But it's definitely a first data point we can anchor on.
So interesting conclusion for implementation is that if we do have read access list, we probably want to spawn as many threads for transaction processing up to the number of threads we have on our CPU. But if we don't have read access list, we probably want to spawn more threads on transaction processing than we have. They will be stalled. So that's an interesting point for the implementation.
Yeah, well, I think the reason I was asking about how much CPU is it got, the problem is if you dedicate CPU to reading, you're not dedicating CPU to computing transactions. So there's going to be a trade-off there, potentially.
Yeah, but I mean, like in this particular scenario,
And same for the block,
which
for the post statehood, I guess, right?
Yeah.
Perfect. Yeah. Thanks a lot, Gary, for the benchmarks. This is super helpful.
Gary,
Yeah, go ahead.
Gary, you were starting to say something, and can you
hear me?
Yeah, I can hear you.
So what I'm trying to say is that if we think that the read is underpriced, so the worst case will be a block with all the S load, with basically no EVM computation. So in this case, if we dedicate all the CPU cost to the S load, it should be fair, because there is no other EVM computation, and EVM computation is like way more faster than the disk read.
Is that realistic? Is it even possible to do like only S loads without any computation in between?
I'm not so sure, but I guess it might be feasible to have some specific program to like to do the, for example, external code hash for a non-existent account. And this address could be generated like randomly. In this particular scenario, it will basically touch all the pieces of the database, so we can avoid the data locality in the cache. It should be possible to crack such block to slow down the block execution, even with the current mainnet.
Okay. Thank you very much. Yeah. Is there anything else on that topic? Otherwise, let's get to the last point in the agenda, namely in-person meetup at DevConnect. So we have space at DevConnect that we can meet up and discuss everything around block level access list progress. There is no daytime yet, so this is still something I will work on, but I will keep everyone updated and also make sure that people that are not at DevConnect will be able to join via Zoom or Meets or something. But yeah, just as a heads up, we might meet and discuss things like the gas limit, the reads, and so on at DevConnect. Perfect. Before we end the call, is there any open topic we should discuss? Anything else we forgot that is like important until the next breakout call in 2 weeks?
I
Just on
mentioned.
what, sorry, just on
Go
what
ahead,
Philippe
Stefan.
said, there are like the debugging, there's just the hash if there's a mismatch between the bows in the logs, but there's a debug endpoint that Bezos implemented. Maybe other clients might want to look into implementing that, where they have the bad block that they disagree with, and they have the access list that they generated, so it's easy to compare.
Good point. Yeah.
Yeah.
Thanks, Stefan, for bringing that up.
Yeah, that's a nice second step too, though. I feel like because we have so many Hive failures, if we had this in the debug logs, it would be quite quick to just have them to compare against each other. Something Mario from Steel brought up is it would be good for a feature like this if we had tracing aligned too at some point. I mean, this is somewhat in the future, but how we do EVM tracing, but we can trace what the bow is doing for each client. But this debug log of the full bow on errors would be quite nice, I think.
Yeah, having spent the last several months debugging parallel flows, that would be definitely useful, because you end up needing, what you want is one that worked and one that didn't, and to do a compare of them. Otherwise, it's like really difficult to work out what the hell's going on.
Yeah, exactly.
Yeah, so this endpoint, has it got a specification? Is there something we can copy so we don't do something similar but different? The basic one you mentioned.
I don't think it has a specification. It basically just dumps the block as a top level key, and under it, it's the generated block access list as another key, and that's pretty much it.
Right, so it's basically just the block, and so in the response, it's the block and the bow, basically.
Basically, I can share in the channel, in the research channel, I can share an example as well.
Yeah, no, that would be great, just so that we don't, because we might as well just copy it, so we're producing the same thing.
Yeah, and in the spec I shared above, I also shared the curl request to get it. I'll also share an example there. Yeah.
Yeah, no, that would be brilliant, just so that, because we'll definitely implement it, because I think we need it, basically.
Sounds great.
Yeah.
Perfect. Awesome. Then we're at the end of the call anyway. Thanks everyone for attending, and see you at the next one in 2 weeks.
Okay.